Number 8, we want to know how many possible 5-card hands from a standard 52-card deck would consist of the following cards: 2 clubs and 3 non-clubs. So this is also a problem that's going to be yielding itself to the fundamental counting principle in connection with combinations and permutations. Let me see if I can pull up a example of playing cards for those who don't play cards, so you can kind of see where I'm coming from. Let's say card sample space. This one looks good. Okay, so when it comes to playing cards, there are 4 suits. There's clubs, spades, hearts, and diamonds. And there are 13 of each. And 13 times 4 will give you 52. There are 4 of each card, 1 in each suit. These 12 cards are considered face cards, and then you have the numbers 2 through 10, and then you have ace. Ace could be high or low, so sometimes you can count this as a 1 through 10, or you can put it on the top and it can be the highest card. So this is the scenario that we're going to be using to compute the playing cards. So you need to be familiar with playing cards, the suits, the breakdowns, and everything like that. So the first scenario wants 2 clubs and 3 non-clubs. Okay, so out of 52 cards, we're going to break it down into 2 groups. There are 13 clubs, and there are, if you take 15 minus 32, there's 39 other cards. We want 2 clubs and 3 from here. So we're going to do 13, choose 2. We have to multiply. 39, choose 3. So this is going to make a 5-card hand. These 2 front numbers add to be 52. The 2 back numbers add to be the 5 that we're choosing altogether. So we're going to do 13 factorial, and then 13 minus 2 is 11 factorial times 2 factorial. All right, and it's going to be times, it's going to be 39 factorial, and then 39 minus 3 is going to be 36 factorial times 3 factorial. And since this is being multiplied, I can reduce across, diagonal, or whatever I want to do. I'm sorry, it has to be top to bottom, or top to bottom diagonally, not side to side. Okay, so let me be careful with that. All right, so we're going to spell this out. So we get 13 times 12 times 11 factorial. I'm going to stop. The 11 factorial is going to go away. And then we have the 2 times 1, which will reduce and become a 6. So we just have 13 times 6 right here. Over here we have 39, 38, 37, 36 factorial. We're going to stop because we got a 36 factorial down here. Those will divide out, and then we have 3, 2, 1. So look, 3 times 2 times 1 is 6. It's on the bottom. This 6 can get rid of this 6 on the top. So at the end of the day, we're just left with the 13 times 39, 38, and 37. So 712,842. 712,842. B, 4 face cards and 1 non-face card. So again, I have to break these down into 2 groups, face cards and non-face cards. This is 8B. Face cards, there were 12, and we want 4. And then out of 52, there are 40 other cards, and we want 1 of them. So we're going to do 12 factorial. 12 minus 4 is going to be 8 factorial, and then 4 factorial. And then over here, we're going to have 40 factorial. 40 minus 1 is 39, and then 1 factorial. Spell this out: 12, 11, 10, 9, stop at 8. 8 factorial, we'll divide out, and then 4, 3, 2, 1. 4 times 3 is 12. 2 times 1 is 2, and 10 is divisible by 2, leaving us with 5. So 11, 5, and 9. Over here we have 40 times 39, and we'll stop there. 39 factorial. 1 factorial is still 1, so we have the 39 factorial. We'll divide out, so that just leaves us with times 40. $11, 5, 9, 40, 19,800. C says 3 red cards, 1 spade, 1 club. 3 red cards, 1 spade, 1 club. We have to find out how many ways can we pick 3 red cards. So we have to do, there's 26, half of the deck is red. So we're going to choose 3 of those. And then we want 1 spade. So there's 13 spades. We're going to choose 1 of them. And then 1 club. So there's 13 clubs. We're going to choose 1 of them. So 26 factorial, 26 minus 3, 23 factorial, another 3 factorial. And then we have 13 factorial. 13 minus 1 is 12. 1. Rule of thumb is if you have any number choosing 1, the answer is that number. There's 13 ways to choose 1 if you have 13. So, but just to show the formula, 13 factorial, 13 minus 1 is 12, and then just the 1 factorial. All right, so I'm going to start reducing. 26, 25, 24, 23, and stop. 23 factorial, 23 factorial, those will divide out. And then 3 times 2 times 1. This is 6. 24 is divisible by 6, that will leave us with 4. So we have 26 times 25 times 4. And then each of these, 13 times 12 factorial. 12 factorial will divide out, leave you with 13. And the same thing here. So 26 times 25 times 4 times 13 and another 13. So 439,400. That should work out.